next one is just a problem similar to the last one that we did. So we are working with the point 4, 7 pi over 6. Once again, this is a polar point, not a rectangular. So the 4 is our radius, the 7 pi over 6 is our angle. So if we want to go ahead and just graph the point, 7 pi over 6 is here. 4, we're going to go from our pole, and we're going to count 1, 2, 3, 4 spaces. So our point is right there. So then from there, we want to write 2 other names for this point. So I like to just do the backwards one first. So because we have the graph with the backwards one, you can just look. So 7 pi over 6 connects with pi over 6. So the backwards one would be negative 4 pi over 6. And once again, let me explain why. If you're at pi over 6 and I told you to go backwards 4 spaces, you would end up there. If you needed to get those algebraically, this time because 7 pi over 6 is on the second part or the third quadrant, you would want to subtract pi. So if you were to subtract pi, which would be 6 pi over 6, that would give you pi over 6, and that's where that number comes from. So this is one possible answer. Remember, this pi over 6, you could add 2 pi over and over and over again, or subtract 2 pi, and it would still give you the same thing. If we want to just do one that's going to be coterminal, I could take my 7 pi over 6, and if I want to add 2 pi, so I could say at 19 pi over 6. So another point could just be positive 4, because we're just doing the coterminal one, 19 pi over 6. That could be another possible answer. If I wanted to get a different one, I could have subtracted 2 pi instead, or I could keep going on forever. So then it wants us to give all the possible names for p. So to do all, remember this is where you have to involve the n value there. So I'm going to take my original point 4, 7 pi over 6, and we can add or subtract a whole circle, which will be 2 pi n. Okay, n is just an integer, 0, 1, 2, and it keeps going on forever. Then we want to use the backwards point. The backwards point we said is negative 4 pi over 6, and we could add or subtract 2 pi over n to that pi over 6, and this will give us all the possible answers that we could get for just this one point on this polar graph. Okay, so hopefully you realize now that one specific polar point on your graph can be named in an infinite number of ways. Alright, so next thing we're going to be doing is converting polar to rectangular, rectangular to polar. So, if we're going, so the polar points are in the form r theta, and if we want to change them to rectangular, rectangular points are in the form xy. So there are some formulas that we're going to use for this. The first formula is x equals r cosine theta. And the other formula is y equals r sine theta. So where do these come from? So let me try to draw this on here. So if I was to pick a point, let me just pick like this point right here. So if I had this point right here, so this would be at 1, 2, 3, 4. This would be at 5 pi over 4. If I was to do this rectangularly, so I would be, if I was just graphing this point on a regular graph, I would go over x amount of spaces here, and then I would go up y amount of spaces. Sorry, that line's not straight. And then if I was to connect this, the hypotenuse there would be the radius value, okay, because that's the radius and that's how long it is. So, and these are the formulas. I'm just kind of showing you the work for this. So if I was to figure out, and if I was to call this my angle here, if I was to do cosine, remember from SOHCAHTOA, cosine is adjacent. So in this case, and this is my angle, the adjacent would be the x over the hypotenuse, which we just said was r. So if I was to solve this for x, x would be r cosine theta, which is where that formula came from. So same thing, if I was to do sine theta, sine from SOHCAHTOA is O over H, opposite is y over the hypotenuse, which is r. So if I was to solve this for y, y would be equal to sine theta. So when we're converting from polar to rectangular, we're going to be using these two formulas. X equals r cosine theta, and y is r sine theta. Okay, so if we take a look at our first problem here, we want to convert negative to 5 pi over 6, and this is polar, and we want to change it to rectangular. Now sometimes just hearing those words gets a little confusing, so I like to think about these and put the actual variables. So if this is polar, that means this is r and this is theta. And if we're changing it to rectangular, we need x and we need y. So the good thing is, from polar to rectangular is super easy because you just use your formulas. So we know that x is still going to be the formula. We need to find x, r cosine theta. We're just going to plug in. X equals r, which is our radius, is negative 2. Cosine, our angle, is 5 pi over 6. So I am going to reference our unit circle here. So this is negative 2. Cosine, remember, is the x value. So if we go to 5 pi over 6, the x value here is negative square root of 3 over 2. And then if I was to multiply these, the negatives would cancel, the 2's would cancel, so you would just be left with the square root of 3 for your x value. And then I need to find my y coordinate. So y is the formula r sine theta. So y equals r, which is negative 2, sine of our angle, which is 5 pi over 6. So we're going to use our unit circle, negative 2, sine of 5 pi over 6. So we're back at 5 pi over 6. Sine is the y value. So the y value here is 1/2. So negative 2 times 1/2 is negative 1. So this is the polar form. The rectangular form of this point would be the ordered pair square root of 3, negative 1. So this is my x, this is my y, and that is now in rectangular form. Alright, then if we look at the next one, it's just the same kind of practice. So we want to convert 3 pi over 6 into rectangular. So this is polar. We're trying to find rectangular. So guys, polar is r and theta. Rectangular that we're trying to get is x and y. So we're going to be using our formulas. We have x equals r cosine theta. So x equals our r, our radius is 3. Cosine of our angle, which is pi over 6. So cosine, if you look at our unit circle, is the x value at pi over 6, which is the square root of 3 over 2. You just have to ignore my dog for a second. So our x value here is 3 square root of 3 over 2. So then we're going to do the same thing. Y is the formula r sine theta. Y is going to be 3 sine of pi over 6. So if you take a look at your unit circle, sine of pi over 6, sine is the y value. So sine is 1/2. So the y value is going to be 3 over 2. So my rectangular coordinate looks a little strange, but it's 3 square root of 3 over 2, comma, 3 over 2. So this is in rectangular form, and we change from polar to rectangular with x and y.